Welcome to our term project presentation. I am Taylor.
I am Ben.
I'm Graham. And I'm Jack. This is
Our table of contents.
so this is our project overview. Our purpose is to design a complete facility layout for OKKO's manufacturing plan. The scope is we have to do a production, an office spaces, warehousing, parking, and the cost estimations. And our goal is to efficiently produce a layout that's functioning and has a good flow score.
For the machine requirements, we took the given information from the document of the case study, such as the product process times as well as their demands, and using that along with scrap allowance with an assumed defect rate of 2%, we got the total times for each process. For the machines required, we use the given reliability of 95% and efficiency of 95% as well as the total working hours you would expect within a day, and found that in total we will need 7 processors to meet every single product's demand, distributed as shown below. Using our machine requirements and the distribution for each different processor, as well as the from-to charts that we calculated before, we calculated the first layout using the craft software, which is shown here. The flow score for this layout was 29,111, and the final dimensions were 78 meters by 106 meters, with the 20% expansion buffer that we are using for this project. And for this layout, the main separator between this layout and the second layout is the fact that the shipping department is both for intaking raw materials and shipping out finished goods. So it will act as both the shipping and receiving department and also the warehouse, which will be explained later.
So layout 1 was a U flow. We're going to explore the alternative, which is a linear flow. So in layout 2, as you can see, we kept most things very, very similar. That purple block is still the receiving bay, but it's no longer also the shipping bay. In craft, we added in that light cyan block as the shipping bay. So now we can see that there is a linear flow from receiving the purple all the way through to the cyan. And this increased our flow by a lot, actually, coming down from 29,000 to 22,000, while keeping relatively the same dimensions, only about 1.8 percentage difference. So why, if the flow is so much better here, are we going with the layout 1? Well, it's because layout 1 and its U shape has a lot of benefits that are not measurable, like how if you have both on the one side there, capital costs for storage equipment can be shared instead of having to buy 2 separate storage equipments. Additionally, we're going to see later that employees and the annual cost is going to be one of our biggest challenges. And having the shared department means that we don't have to have 2 separate employee groups so that we can hire less employees. So finally, the layout 1 production floor dimensions with a 20% expansion buffer will be 78 meters by 106 meters, which totals to 89,000 square foot. And as you see on the diagram there, that there is that forklift path which allows dual direction movement. And then so all the materials you see in the middle there are going to be the processors with the room for expansion on the left and room for storage on the top as well.
So for material handling within the facility, we determined that there is 5 forklifts required with 1 spare for flexibility, which gives us 6 total forklifts. Handling operations in shipping departments to stock and unstock. And then the daily moves of each forklift would be 999 moves with a total annual cost of just under $14,000. By using the layout generated from craft, the shipping and warehouse section of the production floor was able to be determined as follows. It features a 2-way aisle which separates the dock and the warehouse. The warehouse contains 2 gravity-fed shelves which employees will use to place items in a cart and bring to a forklift to be sent out to the facility. The docking area serves as an area for both the shipping and receiving. And it can support 2 transport vehicles tables and requires a clearance of 20 by 20 feet.
For the office calculations, we were given a adjacency relationship chart within the case facility or the case document, and we plugged that into the Core Lab software using our own described weights. And this was the layout that was given. Expanding on this, we added a central hallway and also merged the three finance department of accounting, marketing, and purchasing into a singular finance department. And the basic layout with all these taken into account is shown on the left. And we further expanded upon this basic office layout to include the other facility requirements, such as a cafeteria, a break room, showing all the toilets, and also a main entrance and reception. And that can be shown here with this detailed layout.
For the employee breakdown, we have a total employee count of 332. The most that you have at once is during the day shift, which is 164. There's many roles on the production floor, which is machinists and forklift drivers and maintenance. In the office, you're going to have administration, production control, accounting, human resource, IT, marketing, and purchases. There are others also, such as gardeners, receptionists, and janitors. And it is our biggest cost with a yearly cost of $30.31 million.
Next, we have ancillary facilities. So per the Nova Scotia Building Code, there must be one toilet for every 15 employees. Given that we have 164 employees who are working at any given time, there must be at least 11 toilets. However, 34 were added for redundancy between two different bathrooms, each having two handicap accessible spots. Fire extinguishers must be no more than 75 feet from ordinary fire hazards. They're typically placed within 50 to 100 feet of one another, and it was then calculated that we will require 35 extinguishers for the facility. Smoke alarms must provide comprehensive coverage of the entire facility and be part of an interconnected system. Our production facility will require 22 smoke detectors, which is at the typical rate of 2 per room within Nova Scotia. Ventilation systems in Nova Scotia must be installed in concordance with good engineering practices, such as the ASHRAE Handbook and Standards or the ARJI Digest. Using the cubic feet per meter formula for airflow and assuming each unit can handle roughly 40,000 CFM, it was determined that 6 units would be required. Then finally, there are 3 types of first aid kits approved in Nova Scotia. Type 1 would be personal, Type 2 is basic, Type 3 is intermediate. Based on the number of workers in the office and production floor, it was determined that the office would need 3 Type 2 small kits and the production would need 6 Type 2 small kits.
For the parking requirements, considering we have 164 maximum employees at a time and using the 20% expansion buffer we are using for this project, as well as 20 visitor spaces, which we assumed based on estimation, the minimum amount of spots that we will need is 220 parking spaces. We also considered other additions to the parking area, such as shade from the trees, disabled parking spots, electric vehicle charging stations, and emergency access for emergency services. And lastly, for the measurements, we have 90-degree parking, 66 feet of module width, and each space is standard 9 by 16 feet. And this is the final parking layout after putting everything together. We met the required minimum required spaces with a total of 228 spaces. The other additions can be seen with the legend that are added, such as the green electric vehicle charging stations. And lastly, we have a service road that snakes along the right to allow shipments to easily reach the docking area of shipping and receiving without having to go through the parking area.
So Graham touched on with the employees on the cost annually. So we're going to take a look at what capital cost investments are required initially. So production floor construction costs will be split into 2 costs, direct costs and indirect costs. So direct costs are very simple things like raw materials, the equipment required, and then indirect costs would be anything from labor to supervisors and things like that. And from the Statistics Canada quote from 2024, indirect costs for last year could be anywhere from 20 to 50% of the direct costs. Leaning into the worst possible case scenario, we calculated that indirect cost is directly half of the total cost. So that brings our production floor cost to $8.6 million. So Aside from the production floor, we also have the office spaces, and office spaces here would be 23,000 square feet. And this, doing a simple calculation, multiplying this value by the value provided in the OKKO case study of 25, we get $578,000. So totaling the two will combine for $9.2 million. So the overall facility financial analysis, we have all the machines, 70 processors equaling $7 million. The land total being $6 per square foot for 230,000 square foot, equaling roughly $1.5 million. And the building costs we have spoke about before, totaling $18 million for the initial capital cost. And then this is just another breakdown for the immediate costs, $18 million for the facility and $30 million for annual operational costs.
So with all the information together, this is our final layout summary. As you can see, we have the office space and we have the production space, and this is our final layout. Thank you. Final layout. Final